Hello, this is Jonathan Tate with Broadcom. Welcome to the community.broadcom.com site. We do a quick walkthrough of the Wicked Smart Designer in our SDK, talk about services and characteristics, and just for fun, we'll pretend we have a beer drone quadcopter. We're going to kind of configure sensors for doing that and kind of have fun with that. Uh, Brief agenda, we'll talk about the Smart Designer and we'll do a system design, only a few portions of a microbrewery. We will, during this fun exercise, configure the services and characteristics and units of the sensors for monitoring various sensors in the portions of the microbrewery. We'll talk a little bit about an imaginary bottle conveyor system for the brewery, talk about how we can monitor the conveyor with the sensors that we have, always configuring things under the Smart Designer. That's really the real point behind this. We'll also go to the beer quadcopter drone, an imaginary drone we have, and we'll do a deeper dive into how to configure these sensors. We'll chat about a few brief ideas for sensor use cases that you might have for that you're thinking about design. We'll talk about an agricultural watering system, a fire drone protection system, indoor earthquake, and looking at the sensors for gyro, e-compass, and accelerometer for maybe controlling or sensing the control of the quadcopter. Here we just have a picture of our imaginary quadcopter. This is the kind of the one that I fly, and haven't picked up any, haven't used these Wicked sensors yet, but I definitely will. We'll show how, again, we'll configure the surfacing characteristics and the units of the sensors for commercial and consumer use cases. Okay, so let's have a little bit of fun with some beer making process, and we'll get the sensors and see how Smart Designer will help us think about the beer brewing. So this is kind of how beer is made, and let's take it in how we analyze this. So with the beer community microbrewing kit, we're going to take, number one, we'll take a chip from the 36. We're also going to remotely monitor the brewing process using Boolean sensors. We'll do the GAT database. We'll do a smart sensor, generate the code, populate the GAT database, and we'll take a look at characteristics. Number one, number two. These are characteristics of what we'll do for each portion of the system. Number three and four, we'll define those characteristics as well. So let's dig a little deeper into the MASH mixer service, where we'll go ahead and take the Broadcom device and have the appropriate sensors with the Smart Designer and the relative humidity, relative temperature. Smart Designer will generate the code for both the GAT database, and the engineer will fill in the details from there. Let's also take a look at the bottling conveyor and the beer drone, which we'll talk a little bit about later. We'll create one of those. So the first and second portion of the exercise will be to create the characteristics 1 and 2. Then we'll go ahead and take a look at the bottling conveyor system, and the engineer will set up the e-compass. We'll take a look at the beer delivery service and the GPS system involved with that. We'll take a look at the e-compass characteristics, fill in the blank, and go from there. We'll use the Smart Designer to let the engineer kind of think of, hey, how do I approach this problem from a macro level? And we'll do that. This is kind of a fun video that I took a look at of how a beer drone would be used in a colder climate in San Diego. But as you can see, we'll take the beer, use some sensors for the quadcopter, take a look at RSSI, and use the Wicked Sense I'll show in a little bit to find where to drop the beer off. And someone just ordered the beer, as you can see. We'll drop it off right near the cabin that ordered it, and someone comes out to join it, and we'll have a little bit of fun with that, and I'll show you the experiments that we did do. Okay, let's start off using the Wicked SDK. We'll do new. We're going to open up Wicked Smart Designer. We'll go ahead and name our particular device name, which will be the beer brewery that we're going to configure, and we'll add the drone a little bit later. So we go ahead and set this up this way. We name it, and as you can see on the project window, beer, the Wicked has been created, and here's the Wicked wizard file at number 1. So when we do that, now we can start configuring each one of the components. We're going to add buttons, UARTs. Let's take a look at the timers. We're going to add an LED, a buzzer, battery, find timer, and we'll do over the air. When we do this, the lower menu here has device settings, characteristics, and stuff like that. So what we'll end up doing is showing, number 1, we're going to set up the, for instance, the relative humidity. So that's shown on the characteristics, and we're going to measure that particular characteristics at number 1. When we do that, we can also have to provide an initial value. I'll show you that later. But here, once we do that, number 2, we're going to take a look at the formats, what we're going to use for humidity. That's going to be percentage. And then what we'll say is, well, let me try the MASH mixer service, and I'm going to go with vendor specific characteristic here. So when I take a look at this, since I named it the Beer Brew Drone, I have to go ahead and change that. I changed, number 1, the service name. When I change the service name, I also can change the name of the characteristics. We'll show you a document you can refer to number 4 to find out how to do this. So from here, we're able to go ahead and modify the name as relative temperature. We also take a look at relative temperature and say, let me see, at number 6, let me name that specific description of the characteristics. So we're going to go ahead and do temperature. So we label the temperature, and what ends up happening when we do the MASH mixer service, we also add some of the properties. We can do read, modify, read, write, all the permissions that we need to. Plus, when it comes to the format of the temperature, obviously we need to go ahead and say this is the second description of that. And we're going to go ahead and make sure that for relative temperature, we're going to find the appropriate units, which we select as degrees Celsius. We add that, and now you can see that the characteristics here. But let's add another one. Now we're going to add, we've added those 2 for relative temperature. But what we also want to do is we want to find out specifically what to do when we add another portion under the MASH mixer service. So we do that, we go down to the bottom, and we say, okay, as from the GAT database, let me go ahead and assign one more different service. So I go ahead and select a particular service. And so for MASH mixer, I did that as part of the beer system. The next thing I want to do is add another service. Remember our system diagram for the beer brewing. What I need to do now is name it the other particular portion of the beer brewing system. So when I do that, I'm saying, okay, now what was, as an engineer, I'm thinking, what were the other components that I really needed to look at? That particular component, obviously, I'm going to have to change that name. So when I go to the Wicked Smart device, I say, at number 2, the other part of the system was the bottling conveyor system. So I'm going to do the bottling conveyor system, and if you think in a bottling conveyor system, I have to go ahead and have an assembly line of what happens. So I go ahead and change this particular service description to reflect what I want in my bottling conveyor system. Remember, we're trying to emulate as many of the sensors as possible, so we select a vendor-specific characteristics under the bottling conveyor service. When we do the bottling brew drone, we change that name and say, okay, what is the next portion of my system? As an engineer, I'm thinking, what do I have to change next? So I take a look at this and say, let me select a particular name of the characteristics. Now remember, I have a gyro and accelerometer, meaning I'm going to measure the gyro, the pitch and yaw of the conveyor belt, and I need to go ahead and use the accelerometer for that as well. So here we have that. At number 6, we're going to go ahead and change the service description, saying this is part of the conveyor system, and I need to measure whether there are going to be the conveyor is on, off. If I'm bottling, I'm putting labels on these. All of these are going to be part of that particular service description underneath the bottling conveyor system. So at number 1, I also have to change the description. And since this is a vendor-specific characteristics, we're doing the bottling beer and drone that I'm going to add a little bit later. We'll talk about the drone, beer drone, a little bit later. So once we add this at the number 1, I want to go ahead and specifically add another characteristics under the bottling conveyor system. When I add the vendor-specific characteristic here, I'm also going to say, what is another thing that I want to measure in my bottling conveyor system? So what I will do is I'll say, let me see, I really want to go ahead and make sure under the gyro and accelerometer, I have to change this at number 4. And I'm going to go ahead and measure the direction of which the bottles are going on the conveyor system. So I do that using the e-compass and the magnetometer to say, hey, am I going up or down? What level of the brewing bottling conveyor system am I there? So I do that, and I add the e-compass and magnetometer just like I would the under the mash mixer service, where I had humidity and I did the relative temperature. All of these as I'm developing what am I thinking about with respect to each one of the parts of the system. The bottling conveyor system, yes, I'm going to have a gyro and accelerometer sensors on my Broadcom device. So when I take a look at this on the name of the characteristics, obviously I want to change that. So I do this and I say, let me go ahead and be a little more clear in trying to show what my Wicked Smart device is doing. So after I configured this, what I did is saying here, this is my Wicked Smart device file, WIC. I have the beer drone at number 1, and then I go a little bit further and saying, what have I configured just with this Smart Designer? Lots of stuff that I've done just from selecting the menu. Here's my beer brew drone as part of my characteristics. I'm taking a look now at the code in the wizard file for the Smart Designer. I also see that I have defined a few things, for instance, e-compass and stuff like that. Now what I do is I generate the code here, but it also checks for errors saying, what haven't I configured? Like, well, wait a minute, I have a device code for characteristics on my relative humidity. Oh, I forgot that. So I said, oh, I got to add some bytes. So let me go ahead and assign the bytes for that. So that's my relative humidity. I try to generate the code again and I get an error saying, oh, I forgot about the relative temperature. So let me go ahead and do the assign the 2 bytes that I'm going for that characteristics. And I keep going further and further, and it helps me debug my actual software. So now each one of these characteristics for the services, I'm adding the bytes, and finally for the beer drone later where I add 2 bytes. When I do that, the generate code says it generates database files. So I didn't get any errors, that's great. So when it generated files at number 1, I start seeing, hey, what has been created for me? And I've got these database files now that are created for me. And you'll be able to see that I have db.c and db.h, and I had a backup of what I had before. So now I'm going to open up what the wizard has done for me in a db.c, and we'll see the code. The code shows me now, this is my real code, and number 1 and 2 shows me what I've done as far as configuring things. I've got the beer brew drone at number 1 configured as a device setting. Also my appearance was a generic tag. We go ahead and move on to the next one, number 2, where I have the beer brew drone. This is the vendor specific characteristics that I assigned. And here at number 3, you see relative temperature, relative humidity. All of these are, and here's the bottling conveyor system at number 4. If you recall, I did that. Number 5 was the beer drone that I had done here that shows everything that was, hey, here's the beer drone database. So again, each one of these is what I have done and opened up and showed what are the characteristic UUIDs, what actually has been done for me. You can see at number 1, it's labeled the beer brew drone, so I can go ahead and find that. At number 2, it's also showing me the relative humidity and the mash mixer relative humidity for that. Next we have number 3 is the mash mixer temperature configuration for the client. Below that was the bottling. Here at number 5, we got the gyro for the bottling conveyor system and the conveyor system for the beer drone. So each one is doing, it's helping us to define at a macro level, here's my beer drone and the format that I have, and I'm configuring as I go through this code. Here's the mash mixer service. I have the beer drone register timer that I need to go ahead and do if I have a timeout on that particular characteristic. Also, moving forward, I take a look at everything that's been configured for me, that the host info and all of my beer. Number 3, everything from the bottling conveyor system had just been configured. Here's my relative humidity with that particular hosting information, and everything that I need to go ahead and configure that I did when at number 4, relative humidity, I did that. Everything is configured exactly for me the way that I thought. So moving on, this is all C generated code that was done for me. Browsing through the code, you can see a few things that have been done, and now let me take a look at that. Okay, now let's go ahead and do a new wizard file for our Beard drone and add some of the sensors to it. We'll go through the same kind of walkthrough, but now we'll do it for a different application. So we're going to be calling this the Wicked drone. Again, going through all of my configuration at number 2, I'm going to say these are all the things I want to use on my Wicked drone. I'm going to have spy interfaces, battery monitoring, looking at all the bonded devices that I want to bond with. I'll show you the 4 that we're looking at on the Wicked drone. So we want to support over-the-air upgrades, and we'll do that. Okay. So now what we do is we have, as we did before, the GAT and generic device attributes that we're looking at. So what we want to do is add each different service and its appropriate characteristics. We do a vendor-specific service since no one's done a Beard drone before. So we're going to add that service and say, okay, what's the Wicked drone going to look like? That's the particular service it's going to have, and what are the characteristics and all of the things we need to measure. So we label this, and this is a vendor-specific service. We'll delete that since you learned that in the last lesson. So under here, what kind of things do you need for the drone? We'll add vendor-specific services here under or a particular characteristics, and we'll say, okay, here's the drone. Let me add now either a service or an appropriate characteristic. Here we'll add a characteristics to the Wicked drone. So each component of the Wicked drone, we want to say, number 1, what do I do? I want to name this as, number 1, the humidity temperature sensor. I want to sense that from my drone, specifically for where I'm delivering the beer. The Wicked drone would say, I want to know the humidity temperature. Do I deliver the beer if it's raining? Here I wanted to add interesting things. There are lots of things other than the Beard drone, but for instance, applications like the sprinkler system for a home, or an agricultural field. These are lots of applications that an engineer will use to say, hey, what do I want to design? This is the particular sprinkler system, and I need to measure the humidity of the water sprinkler system and what temperature. When do I water my crops? Water my crops. So I do that, and so this is a specific characteristics of my humidity temperature sensor on my Wicked drone. So I add these, and suppose, hey, I also want to go ahead and do the plant moisture systems if I'm in an agricultural environment. I can read and write. I define my permissions, what the host is going to do, notifications, indications, and that's what I'm doing. So the home and agricultural is a characteristics. I'm going to select another characteristics under my humidity sensor and say, okay, what else do you want to measure? Well, the engineer thinks, let me go ahead and consider under the humidity temperature sensor, I'm going to go ahead and do a home security for the washing machine leaks. If my washing machine breaks, the insurance company would love to know that. They wouldn't charge me as much. I'm going to go ahead and add this as a characteristic to my sensor. And if the washing machine leaks, it'll send me an alert to my iPhone or my WickedSense Wi-Fi. So now I have just defined what that is with respect to the humidity temperature sensor. So description of that would be, yes, the same thing that I had done before, where the service description, I want to say, again, now I want to say this is the service description where I use the same Wicked drone to say, hey, I want to put it out for the forest fire with the rangers. So hey, if I go ahead and do a fire prevention system, what can I do? I can measure the temperature, and perhaps I'm going to use something else, maybe another sensor on my drone, which is barometric pressure. So I'm defining this as an engineer as I'm thinking. No code is being done here by me. I says, what can I do? Now, another part, if I click generic attribute, I want another service in there. So the service that I'm going to use now at number 2, I'm saying, let me do a barometer. Again, with my fire detection system, I can find out, what is the barometric pressure of the force that I'm using? What's the barometric pressure of the sensor that I want to put in my home? So in this sense, an agricultural sensor from the Wicked drone would be able to sense in an agricultural field, what's my barometric pressure? How does that relate to different things that are going to be in my agricultural sensor? So again, I need an e-compass where my drone flies around where I can measure this. And again, all of this e-compass, these sensors are on our Wicked Sense kit that I'll talk about a little bit later on. So you see how what I'm doing now using the Wicked Smart Designer is I'm defining my system architecture using this. So again, all of this is just a very interesting GUI where I'm going to say, hey, I want to do micro-based location, perhaps for the fire drone that I want to do. I came up with an application at a previous lifetime, say, hey, what do I want to do with specific to micro-based location using GPS when there's no GPS in the building? If I have a particular fire and everything's I send in my Wicked drone to accommodate for that. So one sensor was let me add another characteristics next to my e-compass for a fire protection system. Again, here in California, let me go ahead and take a look at an earthquake rescue mission when I want to map the indoor of a building when it's been decided that, okay, here's my indoor and I want an earthquake. Something happens, there's no Wi-Fi, there's nothing else. So I send in the Wicked drone to go ahead and take a look at indoor micro-location for the specific rescue mission if a building's down and we can rescue people in the building. So again, this is how the engineer from a system level thinks. Here, this is my indoor rescue mission. I want to map the building, and I can do that with my Wicked drone. Again, you have no GPS inside of the building, so I could use the Wicked drone as a Bluetooth low energy micro mapping environment. So I do this, and now I have configured what we're doing for, again, another service under my Wicked drone. So the Wicked drone says, let me do another characteristic. I want to add it under the general attribute tab. And when I do that, now I'm getting more and more system information. If I'm in, again, the hydrometer, hydrometer is kind of used also in the Wicked brewing, the beer drone that I kind of alluded to this. So if I want to go ahead and measure, now most drones don't use the Broadcom device, but they will. So the Broadcom says, hey, I'm going to use these. I'm going to select my barometric pressure and hydrometer for both our beer drone and also to control the yaw and the pitch of the servo system of the drone. Lots of that's done in Arduino, but we can actually do a lot of that with our Broadcom device. So I'm actually setting up things just like that to be able to find out what can I use for the gyroscope and the gyro on the actual props for the drone. So I measure the tilt, yaw, and the pitch. And so now as an engineer, I'm thinking of how to use as many particular Broadcom connected devices to be using. I'm also going to have landing sensors, believe it or not. People haven't really thought about that, but when I go ahead and land, how can I auto land my Wicked drone? I have to have sensors to go ahead and measure these particular things for the drone. The gyroscope enables me to go ahead and make a safe landing. So I'm doing some of the landing sensors as I'm building my beer drone, now known as the Wicked drone. So each one of these things are saying, hey, each time I define something, these are all the components of my Wicked drone. So what you can see is an engineer gets to think, hey, wait a minute, now I need an accelerometer. What do I need an accelerometer for? Yes, for motion. But when my drone is quiet, I don't want any of the sensors on because that'll drain my battery. So I use the accelerometer to motion sense in order to go ahead and, again, perhaps an earthquake drone, if my Wicked drone is being able to take a look at the agricultural, I need the sensing to conserve my battery power. So I only turn on the sensors when I need to. And that's kind of the description that, again, if someone takes a look at that as another engineer says, wait a minute, I need to go ahead and conserve battery power, and I'm communicating at a system level. Here's what I'm doing, guys. This is my particular system diagram from a coding perspective. Again, I can go ahead and do all of the sprinkler systems. I do my configure the units for each one of my sprinkler systems for the home and agricultural. I'm looking at very, very sophisticated things such as, yes, I'm doing my temperature. Again, reading and writing and giving all the permissions that are done in a Bluetooth low energy environment. Client configuration, I need to notify my client to see when things happen. On the format issue, again, we're adding different formats for each one of the characteristics selected for the humidity and temperature sensor. So now again, I'm going through lots of different selections that I have in my Smart Designer to say, what am I going to do for my fire protection system? Well, let me just kind of see and search what is it that I can use in my units. So the units that I finally search and go to the menu and say, okay, let me go ahead and select something that's going to say, hey, this is going to be a percentage for the humidity, percentage humidity. For the E-Compass, again, E-Compass, I have lots of things that I can do with that. In the formatting of the E-Compass, obviously, I have the northwest, south, and in a particular compass units. But everything that I'm looking at, I can kind of, if it's not been defined here, I can go ahead and definitely look at, I picked a ridiculous one for radian for the actual E-Compass and the gyro, units for that. Again, going through, I'm taking a look at all of my system and saying, what can I do specifically to configure everything? So again, this is another idea of saying I'm going to generate the code just like I did in the other one. So when I click to generate the code, everything, the actual wizard device is here. Again, you can see number one, my Wicked Drone is there. Again, everything I configured within the wizard file takes a look and said, okay, what am I doing now? I'm looking at each one of the characteristics that have been predefined. Also, when I do that, I'm looking at humidity temperature sensor that I've defined at number 2. The fire prevention system, you can see at the bottom, I also configured. My E-Compass at number 3 is configured as well. This is just the wizard, the WIC file. Here's the micro base location number 4 for the fire drones. Here I've done the rescue mission at number 1, number 2, the drone landing sensors. So all of these particular sensors are done and measured using this wizard file. The .wic file will say again, the acceleron of motion at number 1. This is the sensing thing. So when I do all of this and I generate the code, as I did in the previous example, again, it shows me all of the code that I forgot. So now what I'll do, without showing you all of the errors, I'll go through each one of my particular characteristics under the service and change all of my byte sizes. So I've configured everything in the number of bytes that I'm going to send in this particular Bluetooth Low Energy characteristic. Each one, again, are characteristics of the previous service that we have defined. Now, when I finally do that, I generate the code, and then you can see what happens here on the left-hand side. When I generate the code, now, number 1, this was the file. Again, I have my db.c file, which has all of my code there, and the backup that I did, my backup 1, for both my header and my C file have been backed up for my header file. So now let's take a look at the .c file and see what's been generated. When I take a look at this from the Smart Designer, everything has been automatically generated. Number 1, automatically done by my Smart Designer. Number 2, I have the Wicked Drone database hex file that's included. Again, from the inclusion, I can also take a look. Hey, here's what I called it, Wicked Drone. Number 3, everything is defined for me. Let's take a look at everything that I did. Number 4 was the temperature sensor, the humidity relative sensor that I'm taking a look at. Everything has defined. My UUIDs at number 1 have been defined. Everything is all within this particular characteristics have been defined. So when I move from the agricultural, now I'm going to go ahead and do the humidity sensor at number 2. My sprinkler systems is defined at number 2. Taking a look and moving on, number 3, everything is the indication, notification. All of this is done through the Smart Designer. Here again, I use the humidity and temperature. Number 4, remember the E-Compass. Everything is defined in my UUID for my E-Compass. Finally, moving on, we look at the number 5. This is my yaw and pitch that is defined from my algorithm. That particular algorithm has been configured, and now this is my primary service. Now we look at motion sensing. Motion sensing here is defined at number 1. Moving on, again, stepping through all the code, what the wizard has done for me. And the wizard will configure things such as the E-Compass, and everything here is just the bonded peers have all been configured for my Wicked Drone. Everything that I have defined in the Smart Designer ends up being here and is listed here. Configuration, my appearances, just stepping through the code to see what are my addresses. First, define the bonded drone address. How can I go ahead and configure that? With respect to each one of what's been going for the indoor rescue mission mapping, as you can see, the yaw and pitch of the servo algorithm, everything is writing the values to the GAT database and all of the sensors. At number 5, here are my landing sensors in case I want to change that. It's configured in the particular code. And now finally, just number 6, we're looking at motion sensors and kind of wrapping up. So this is how the C file is done. Okay, thank you.